Hey everybody, it's Kevin Dewalt from Prolego. Well, there's a tremendous amount of discussion about all the emerging large language models from different companies, but if you actually look at benchmarks, OpenAI's GPT-4 is still by far the best, and there really is no great single alternative to it for getting optimal performance in most business tasks. However, as I've discussed before, GPT-4 comes with a lot of constraints if you want to start using it to build enterprise applications. And those are, it can be slow, there can be latency getting things to generate. They throttle your usage, especially if you go with a service like Microsoft's Azure. There's cost and even some data privacy and security concerns for sending information outside of your environment, and that's a big issue for a lot of companies. So ideally, there are many instances where you want an open source, freely available alternative that you can start using inside your environment to build applications. And so today I'm going to describe the available tools that you have for building the best possible one based on what we know today. Okay, so there are three components to this, and I'm going to describe each one in increasing orders of complexity. At least complexity in terms of what it takes to set up, use, and build it inside your environment. The first is a high-performing generalized large language model, like of GPT-4. Currently, the best one available is called Falcon. It came out about 2 or 3 weeks ago. Actually, I think it was May 31st, so less than a week ago. And if you go onto Hugging Face's Open LLM leaderboard, you can see how each new free model ranks against previous versions. And so you can go there today and see that this 40 billion parameter model called Falcon tends to beat all other alternatives in most benchmarks. So that's step one. And if you can take a model like Falcon and you can deploy it inside your app, your environment, you might be done. That might be good enough for your particular application. The second level of complexity is fine-tuning the open source model to your particular task or business environment. And so that involves, taking the base model and some data or some context in your environment and basically customizing it through some training efforts to make it work better on your specific business task and data. Previously, this was really expensive, and even fine-tuning, because these models are so big and they have so many parameters, could require maybe $100,000 of just compute time or more. However, a couple of weeks ago, there was a methodology called QLoRa, which we discussed previously, where some researchers described a way to fine-tune a large language model with a fraction of the time and the cost. And based on their benchmarks, it looks like you could take a model like Falcon and fine-tune it in less than 24 hours on a single GPU and maybe even a single MacBook Pro. So that's the second level of complexity. The third level of complexity is actually leveraging multiple models together in an architecture that allows you to get better performance than using a single model. We've covered these previously, but I would suggest checking out the Smart GPT video or the Tree of Thought technique that I described a few weeks ago that describes how you can organize multiple models into an architecture inside your environment so that you can really boost performance and get to the GPT 3.5 or even close to GPT-4 level performance. So those are your basic building blocks in order complexity. Obviously, the last one is going to take a couple more weeks. You're going to need to have some data scientists and software engineers actually sit down and evaluate the particular use case in your data and in your environment to see if it works correctly. So that's all that is available today. Of course, the space is going to change incredibly fast. But if you start putting together these building blocks today, you'll be able to more quickly adapt to the rapid changes. Inevitably, there's going to be a more powerful base large language model that is released that's suitable for commercial open source. That could be any day now. And it's primarily because there are large companies like NVIDIA and Facebook and Apple who have economic incentives to invest in the open source community and see more powerful models and ecosystems come into the fold because they can leverage this technology. Since they don't sell models or APIs, they use them. The better the open source tools are, the more money they can make with them. So those are basically the three strategies you have. I hope it helps you start planning your strategies for building and deploying open source solutions inside your environment using large language models. Have a great day.